All right, this one here is a roots and radical fractional exponents practice where the top's just asking you to rewrite it. So remember that anything to the power of 1/2 is just square root, so square root of 5. Anything power of 1/2, so square root of 2. Anything to the power of 1/2 is square root of 36. In this case, if you can take the square root, we do. So, oops, square root of 36 is actually just 6. All right, write the following roots as fractional exponents. Now we're going in reverse. So big base of 41, big base of 25, big base of 73, and you're just putting it to the power of the fractional exponent. So anything that's square rooted power of 1/2, power of 1/2, power of 1/2. All right, here we go again, writing back into radical form, but now it's not just 1/2 anymore. So put the big base of 2, big base of x, big base of 19, big base of 4, and then you're just deciding where does the top or where does the bottom go. So here, did you realize that the 3 becomes the index, 5 becomes the power? Try the next one. 4 becomes the index, 3 becomes the power. How'd you do? Next one is actually fine as just 1/2 because this is invisible index 2 and a power of 1. And last, I think that's a 7. The worksheet's kind of light. 7 there and 6 there. How'd you do? All right, now we're going backwards. So this one you need to go big base 50, big base 9, big base 12, 33, 5, 72. And then you're just deciding how is that fractional exponent going to look. Remember when there's no number there, there's an invisible 1. So this one becomes 50 to the power of 1/3, 9 to the power of 1/2, 12 to the power of 1/2, 125 to the power of 1/4. This one becomes 2/9, 11/7, 3/8, 9/5. Okay, so when it says write or rewrite or convert, we're just going back and forth between the forms, right? But now we're getting into a section that says simplify. For the section that says simplify, these are set up to be nicely done as Tehani using the pink sheet, the toolkit. So get that out and find 64 on the toolkit. And did you notice that 64 could be written equivalently as 4 to the 3rd? 4 to the 3rd to the 2/3. Do you see how those thirds could just cross out, leaving you 4 squared, known as 16. So these are going Tehani method. All right, 625, how could I rewrite that? Did you know 625 is 25 squared to the 3/2, and that nicely makes it set up for us to cross out those denominators, making it 25 to the 3rd power. Next one is 8 to the 5/3. Did you know 8 could be rewritten as 2 to the 3rd power? And then we see that nicely those denominators can cross out as well, leaving me 2 to the 5th. You can rewrite that as 32. 256, did you know that that could be rewritten as 16 to the 2nd power? The 2's cross out, and it just gives us 16. That's like saying the square root of 256, and yes, that's just 16. So those are the simplify ones using Tehani method pink sheet that could make it go really quickly. All right, next are asking us to solve these equations using opposite roots. So how would I get rid of a 2/3 root? I would have to take the cubed root of x, cubed root of something squared. But what if I do this in 2 steps to see if this makes more sense to you? What if I first did everything to the power of 3 so that these denominators could cross out? That would leave me x squared equals 4 to the 3rd. So everything's getting a 3rd power so that this can cross out. 4 to the 3rd is just 64. Then we solve the x squared part. It's just plus or minus 8. Okay, let's do the same thing here. Let's make everything squared so that those denominators cross out. Grab your calculator. 27 That's 729. And cubed root is just 9. So cubed root of both sides is 9. Why is it not plus or minus 9? Because it's an odd root. All right, squaring both sides. The denominators cross out. We get x to the third equals, what's 64 times 64? 4096. I take the cubed root of both sides. And I'm just doing this on a calculator. I don't expect these to be memorized. Cubed root of 4096 is just 16. Because it's an odd root, we do not do the plus or minus. Squaring both sides, x to the fifth equals 32 times 32 is 1024. Taking the fifth root, let's try 4. Yep, it is 4. All right, power of 3. We get that x squared is equal to 25 to the third. 25 times 25 times 25 is 15,625. Taking the cubed root of that to both sides, we get that that is 25. By the way, this was the fifth root of both sides. All right, last we just do the fifth root of both sides of this one. And remember, we can always just do the straight up break it down. 12 times 10, 2 times 2 times 3 times 2 times 5. And this is a fifth root. I'm not seeing any groups of 5 there. So we literally just leave it as the fifth root of 120. So if there is not a group of 5 to take anything out, it is fully simplified. All right, next it's giving us a power where we're going to need to rewrite one side of the equation in order to do an exponential equation where we get rid of the big bases. All right, I think it's 4 to the fifth power that we just did on that last problem. 256 is 4 to the fourth. Yep. All right, so we just converted the 1024 into 4 to the fifth power. And now that we have the same base, we can use this exponential equation equal to that exponential equation. It's like the big bases go away. And then we just solve this, and we get x equals 13. Next, we need to set these up into a same base. For example, 32 is 2 to the fifth, and 8 is 2 to the third. Now that we have the same bases, we can set up these exponential equations and solve. So we get 5x minus 15 when I distribute, 3x minus 3, subtract 3 x's from both sides and get 2 x's, add 15 to both sides and get 12. I get x equals 6 as the final answer. Let me know if you have any questions on solving those. All right, rewriting this one, this is going to become 3 to the negative 1, pulling that 3 upstairs. 3 to the negative 1 power. And then 243 is 3 to the fifth, I think. Let's see. Yep. Now that I have the same big base, I set these exponents equal. Add 2 to both sides. I get that negative x equals 7, so x equals negative 7. Looking for a base of 2. And 64 would be 2 to the sixth. Since it's 1 over 64, it's 2 to the negative 6. Now that I have the same base, I make these equal to each other. 3 times 18 is 54. 3 times 4 is 12x. Minusing 54 to both sides makes negative 60. So 12x equals negative 60. We get that x equals negative 5. 10 to the x plus 3 is equal to 10 to the 1, 2, 3, 4 zeros. Now that we have the same base, we set the exponents equal. On this one, I need to minus the 12 to get it to the other side. And that makes negative 16. And then I need to divide by negative 1. So I get 8 to the x equals positive 16. Well, that can be rewritten as 2 to the 3x and 2 to the 4th. So 3x equals 4. So x equals 4/3. These are called exponential equations. It's something we reviewed way at the beginning of the year. This is coming back up this chapter, and we will be reviewing it in the next 2 weeks to make sure we're ready for it on the test. All right, x to the 3/4 equals, oh, this is like the ones we just did on the front side, sorry. Okay, so now how do we get rid of that denominator of the power of 3/4? We're going to multiply both sides by a power of 4. And so that crosses out the denominator, leaving us x to the 3rd. 64 to the 4th power is a gigantic number. And if I take the cubed root of it, oh, it's perfect. All right, taking the 9th root of this, there is no way to simplify the 9th root of 31, so we just leave it. And how do I get rid of a 5th root? I do power of 5, so x is equal to 2 to the 5th power, which is just 32. All right, down here, they're just having you do a little bit of practice on converting between forms. So I'm going to pause the video here from the radicals and exponent work, and I'm going to send you a second video of the converting between forms work.